All right, I think now I'm recording. All right, guys. So where are we? Yeah, so we're actually almost done with the section 6.1. So yesterday we discussed. I introduced the notion of a probability distribution, right? Where you assign for each value of x the probability of x. So you have your probability distribution, which is like as I said, a table where you assign for each x the probability of x. Then you can graph your probability distribution using the histogram. And then we discussed the mean of a probability distribution, x bar. And we said x bar, that will be the expected number of x, right? And then I think I gave you the formula for the standard deviation, right? So it measures the spread of your probability distribution. So, well, I think I would do. I'll just remind you of the example we had yesterday, and I'm gonna show you again the computations for the x bar, right, and for the standard deviation. All right. So again, so this is section 6.1, and it's introduction to probability distribution. Probability distribution. So just remind you what I said yesterday. A probability distribution is an assignment of probability to each value of the variable x. Variable x, right? And so I think we had a couple of examples yesterday, and so just I'm going to remind you. Let's say this example. So example. Let's say your x represents, so x, the variable x represents the number of prisoners out of five who become repeat offenders. Okay, so that's your variable x, and because it's the number of prisoners out of 5, so the possible values of x are, the maximum number of prisoners here out of 5 would be 5, right? So then x would go from 0 to 5. So the possible values of x here, possible values of x are, so of course first we have 0. So the number of prisoners, of course, can be 0, can be 1 out of 5, can be 2, 3, 4, and then 5, right? Again, because it's a number of prisoners out of 5, right? So anyway, so like here, x can take like 6 different possible values, and we said because x has a finite number of values, then we call x a discrete variable, right? So x here, x is x in this case. So x is we say that x is a discrete. It's a discrete variable because variable because it takes on only a finite number of values. finite number of values. So here it can, so x can be equal to 6 different values, right? So it's either 0, either or 1 or 2 or 3 or 4 or 5. So the number of possible values of x are 6. So that's why we say that x is a discrete variable. Anyway, and then so we had the following distribution of x. Oops. So we have the following distribution of x. Distribution of x. So again, here when I say distribution, probability distribution. So following probability distribution of x. Probability distribution of x. So we when I say probability distribution, I mean a table where you have, so we have the values of x. So this is values of x. So here x can be 0, 1, 2, 3, 4, and 5. That's the possible values of x. And then in your probability distribution, in the second row, we have the P of x, capital P of x. That's the probability of x, right? So yesterday we have this example. So for example, probability that x is 0 is, I think we said 0.237. When x is 1. So again, I think probably I need to mute someone. Christina, you're here. Okay, got you. Thank you. Okay. Okay. Okay, so where's my okay, here. All right, so for example, this number, guys, when I write this 0.237, it means that the probability that x is 0, is equal to 0.237. Converted into percentage, of course, multiply by 100, that's 23.7%, right? Multiplied by 100. So what we are saying here is that the probability that 0 prisoner out of 5 who become repeat offenders is 23.7%. Okay, so yeah, so for x equal to 1, the probability of that x is 1. I think we had, so yesterday we had 0.396 here, and then we had for x equal to 2, probability that x is equal to 2, that's 0.264. Then I think 0.088, then 0.015, and then 0.001. Right. Anyway, so first, we discussed the mean of this probability distribution. So just to remind you here, so the mean. So first. So we have the mean x bar of the probability distribution. So we said the x bar would be equal to, it's a sort of a weighted average. So x bar would be equal to x times the P of x, probability distribution. So P of x is sort of the weight of each value of x. So x bar, we said x bar is actually equal to sum. Right, this capital sigma. This is a summation, right, symbol. So we have x, the values of x. So again, x can be 0 or 1 or 2, etc. Right? Times, so each x, you multiply each x by the corresponding probability of x, and that's how we compute the mean, right, or the weighted average of this probability distribution. And I'm not sure if I computed the mean of this example yesterday, but anyway, we can do it again. So here, so like x bar, the mean, will be equal to, so first value of x is, well, as you can see, the first value of x is 0. So that will be 0 times the probability of 0, that's x equal to 0, it's 0.237, so times 0.237 plus, and then we have 1 times probability that x is 1, that's 0.396 plus, next value of x, it's 2 times the probability of x equal to 2, so that's 0.264 plus 3 times probability that x is 3, so that will be 0.088, right, plus 4 times probability that x is 4, that's a 0.015, and plus 5 times the probability that x is 5, that's 0.01, right? So anyway, so I'm not sure if I did the details here yesterday, but let me just say, so here you need to multiply first, guys. So we multiply like this 0 by the 0.237, so that will be 0, right? Plus 1 times, you multiply 1, this 1 times 0.396, so that will be equal to, of course, just 0.396, right? And then you have plus, so here it's 2 times 0.264, right? So that will be equal to 0.5. So this is, so we have 8. Say it again.
It's 0.528.
Yeah, 0. Did they do these computations yesterday? I'm not sure. Well, but it's fine.
The answer was
Okay.
1.253.
253. Okay, we had the answer. Okay, we compute the, okay. All right, thank you, Anine. Yeah, I'm gonna just finish the X bar because I'm not sure if, I don't think I did the standard deviation anyway. So and we need the X bar. Yeah, we need the, so we need the X bar. Yeah, so then next you have the 3 times, that's 0.088. So that's actually 0. Let me see my notes. So this is 0. So 3 times 0.088. So that's 0.264 plus 0.06 or 0.60 plus, oh, I forgot to multiply. So last x is 5, right? So this is actually 5 here. This is sorry, this is 5 times the 0.001. All right, so that's 0.005, and I think we said the answer is 1.253. So that would be the X bar. And we said, so what does it mean for X bar to be equal to 1.253? So it means the following, the expected number, so this is the expected number of X. And what's X? X, that's the number of prisoners out of 5 who become repeat offenders, right? So this is the expected number of X, of the variable X. So in other words, the expected number of prisoners out of 5 who become prisoners out of 5 who become repeat offenders is 1 point. That's the 1.25. So at least one prisoner. So what we are saying here is that at least one prisoner out of 5 become repeat offenders. All right, guys. Any questions so far? This is for the X bar. That's for the mean. So what you need to keep in mind, of course, how we need to know how to apply the formula, right? And you need to know the interpretation of the X bar, right? So the X bar, that's the expected number of X. All right, so next, so we have the mean, and then we can compute the standard deviation of the probability distribution. So so the standard deviation of the probability distribution. Okay, so just to remind you why the standard deviation is useful. So we use the standard deviation, of course, so why this is useful. So why it's useful, why the standard deviation is useful. So we use the standard deviation, of course, to measure the spread of the probability distribution, and why. So why is the standard deviation is useful? Well, the answer is we can use it to compare the spread of the probability distribution about the mean, the spread of the probability distribution about the mean, about the X bar. So in this example, so the standard deviation S. So we're gonna compute the standard deviation using two steps. So in the first step, step one, we're gonna compute the variance. So variance S squared, which is actually just equal to the weighted average distance from X, variable X, to the X bar. So that would be X minus X bar. So the variable X minus the mean square. Of course, we have a summation here. This is a sum times, so the weight, which is the probability of X. So again, the mean, this variance, this is actually, so X minus X bar square, this is the square of the distance between X and X bar, right? When you take the difference between two numbers, that's basically the distance between the two numbers. So this is like the square of the distance between X and X bar. And then you multiply by the probability of X. So that's like the weight, the associated weight to the value of X, right? So this formula, this formula represents, so this formula represents the square, represents the square of the weighted distance, between X and X bar. So it's a weighted distance between X and X bar. And then, so that's the first step. You need to compute this S squared. So let's do it like in this example. So like in our example, so S squared would be equal. So we start with the first value of X, right? The first value of X is 0, right? You start with the first value of X, possible value of X is 0, right? This is my first possible value of X, it's 0. So when X is 0, so we're gonna have, it says, so the formula says, so it's 0, right? This is 0 minus the mean. So the mean, that's the, no, that's what we computed in the previous in one here, right? So and the mean, we said it's 1.253. So I'm going to have 0. That's the first value of x minus the mean, which is 1.253 or 1.25, let's say. Let's keep it simple. And then there is a square. Okay, take the difference and then you square times the probability that x is equal to 0, right? Because my x is 0. So this is the probability that probability of x. So when x is 0, probability that x is 0 is 0.237. So we need to multiply by the 0.237. So here, multiply it. So this is multiplied by 0.237, right? So again, this is just a probability that x is 0. All right, so this is when x is 0 plus, right? Because we have a summation here. Next value of x, of course, is 1. So we're going to have 1 minus, it's the same mean, which is 1.25 square times the probability that x is 1, which is 0.396 plus next value of x is 2. So 2 minus 1.25, it's the same thing, the same mean, times the probability that x is 2. Probability that x is 2 is 0.264. Again, the probabilities, guys, they are just from your probability distribution, from your table, right? When x is 2, probability that x is 2, that's 0.264, right? That's how I got the 0.264 from the table. Okay, you see this number right here? So that's just from the table. Plus next value of x is 3. So that's a 3 minus, again, the same mean times probability that x is 3. That's 0.088 plus when x is 4. So that's 0.015 and plus when x is 5. That's 0.001. All right. So that'll be equal to. So first, guys, you need to do the subtraction, right? So here, there's subtraction, right? The 0 minus negative 1.25, right? Etc. There's 1 minus 1.25. So you do the subtraction. So like here, it's 0 minus 1.25. So that's negative 1.25. And then there is a square times 0.237 plus next subtraction. It's 1 minus 1.25. That's negative 0.25. And then there's a square times, so 0.396. Next, it's 2 minus 1.25. So that's 0.75 square times 0.264, right? So here we do the subtraction. Next, it's 3, as you can see, this is 3 minus 1.25, which is 1.75. So it's 1.75 square times 0.088, etc. And next, it's 2.75 square times 0.015. And then that's 3.75 squared times the 0.001. Now, after the subtraction, okay, inside the parentheses, we had the subtraction. Now we can do the square and we can multiply, all right? So for example, you can do the first, we do the square. So for example, we have negative 1.25. So the square here, because of the square, all the numbers, they're going to be positive. So, I mean, negative 1.25 square, that will be positive. Okay, that will be a positive number. All right, so that will be equal to actually 1 point. So this is 1.5 625. Okay, so negative 1.25 times negative 1.25, that will be positive. Okay, so your answer cannot be negative, guys. So the S square variance, anyway, so it has to be positive. So times, of course, 0.237, etc. So you do the square. So plus, so you have 0.25 square, right? So that'll be equal to 0.0625 times, 0.396, etc. Okay, I'm gonna just write down, unless, of course, well, I have the answers, of course. So 0.75 square, that's 0.5625 times 0.264. We have 1.75 square. So that's actually equal to 3.0625 times 0.088 plus, etc. So 2.75 square. So that's actually equal to 7.5625 times 0.015. And finally, that is the 3.75 square. So that's like 3.75 times 3.75. So they'll be equal to 14. So this is 14.0625 times the 0.001. Okay. And then, guys, once you are done with the square, you can multiply. So for example, I'm gonna just probably give you the first the answer for the first multiplication here. So like here you have 1.5625 times 0.237. So that'll be equal to actually 0. So this is like 0.37, I think 0.37, let's say, right? So 0.37 plus, etc. So you have the next multiplication here, etc., right? So plus, etc. And yeah, so the final answer actually is, C. So it's L1 so this is actually equal to 0.9409. So that's your variance. That's your S square, and then and then in the step 2, your standard deviation, of course, would be just the square root of S square. So standard deviation S. Standard deviation S. That's the square root of S squared. So that's the square root of 0.9409. And so then S is 0.97. Okay. So this is the standard deviation of our example. Okay. Any questions so far, guys?
So for the
chat, okay.
For the square, that's the variance, right? On the bottom. Then we take that and then we do the square root of that, or that, right?
Yeah. That'll be the standard deviation. Yeah. Just be careful with the minus, because from my experience, I know sometimes the students, they get confused with the minus. So here with the square, everything becomes positive. Okay, it's the square of a negative number, it's positive. Because if you end up with a negative answer, the variance, it has to be positive, it cannot be negative. Okay, so just be careful with the square. So sometimes you have the square of a negative number, but the square of negative number has to be positive. So everything, so at the end of the day, everything is positive. Okay.
Oh, okay.
Just be careful with that. All right. So we can have a similar problem, or we can move to the next section. I think it's probably a good idea to at least to practice at least one more time this the standard deviation. So again here, so what we are saying with the standard deviation, so if you have like two probability distributions, then you can use the standard deviation, of course, to say, well, one probability distribution is more has more variation or is more constant than the other one. Okay, so we can always use the standard deviation, compare the spread of two probability distributions. All right, so let's have one more exercise at least. Okay, so exercise. And we're going to try to compute the X bar, the mean, and the standard deviation, right? So I'm not sure if I gave this example yesterday, but anyway, so let's say X represents the number, let's see, I don't think we compute the X bar for this example with the number of fish. Or I mean, we can also do another different example. But okay, let me. I think we didn't compute the X bar of this example. So yeah. So let's say X is the number of fish caught in a day. Okay, and let's say we have. Let's see. Let's say we have 200 fishermen with the following number of fish caught in that day. So did we do this example yesterday? Let me just check my notes. I think we did, right?
It was 100. Yeah.
We computed the. Okay. So let's just.
We didn't find.
Yeah. Okay. Let's just do a different. Yeah. Let's just do a different. I'm gonna just do a different example. So I'm gonna this is a number of let's say X represents the number of kids. Okay, and we have a survey of 50 couples with the following results. So X represents the number of kids, number of child, and so here X. So here first we have 0, 1, 2, 3, and then 4. And then we have, so this is 4 here. And then here, this is a number of couples. For example, the number of couples with the 0 kid is actually 15. The number of couples with 1 kid is 20. The number of couple with 2 kids is actually 5. Then number of couples with 3 kids is 4, and then we have 6 couples with 4 kids. Okay, so as you can see, of course, the total number of couples is 50, right? I mean, 15 plus 20 plus 5 plus 4 plus 6, that will be 50. All right, guys. So first, so you need to find. So first, find the probability distribution of X. Distribution of X. Of X. 2, you need to find the expected number of kids for, so find the expected number. I think I need to meet someone, I guess. Sorry about that. So find. So find the expected number of kids. Number of kids of randomly selected couple. Three, you need to find the standard deviation of the probability distribution of X. Find the standard deviation of the probability distribution of X. Distribution of X. Okay. So so for number 1, guys, when I say find the probability distribution of X, of course, you need to find the probability of each X, right? Probability that X is 0, the probability that the couple has 0 kid, probability that the couple selected randomly, of course, has a 1 kid, etc., etc. So we need to find the probability for each value of X, right? That's what we do in number 1. Number 2, we need to find the expected number. So expected number of kids for a randomly selected couple. So that would be the mean, X bar, right? And 3, of course, it's just a standard deviation. All right, guys, I'll give you a couple of minutes if you can, try to at least, at least find the X bar and try to compute the standard deviation, because I think standard deviation is not, I mean, it's more complicated than the X bar for sure. All right, so we have a couple of minutes, guys. And of course, I'm here to answer your questions if you have any. Oh, Let me just say, guys, I'm gonna give you just the answer for number 2. So for number 2, I mean, just if you want to compare, if you want to check if your answer is correct. So I think the answer for number 2 should be, so here the answer for number 2 should be x bar, the mean, equal to 1.32. Because the thing is, if you get x bar, if your x bar is wrong, right, number 2, then of course the standard deviation is going to be wrong, right? Because the formula standard deviation, we use the mean, the x bar. So if your x bar is wrong, then your standard deviation is going to be wrong. Yeah, just be careful, because yeah, so if you get the x bar wrong, then your standard deviation is going to be wrong. Let me see the chat. Anything? Okay. So please let me know if you can get the, oops. Okay, what happened? Right, you see the whiteboard, guys? You see the board?
Yeah.
Yeah, okay. Okay. Thank you. So did anyone get the 1.32? Just make sure that I have the right answer. Well, I think it's 1.32, but just make sure that my answer is correct. me see the chat. Chat. Okay. Oh, there's something in the chat. Oh yeah. So you're computing the standard deviation, I guess, right?
I'm getting tired. So actually, in the test, I don't think you had to compute the standard deviation, right? There was you had to compute the sample correlation coefficient R, but not. I don't think you had to compute the standard deviation, right? S in the test. Yeah, it was. I mean, because both computations they take time. So I had just to decide. I mean, I had to decide which one I'm gonna put in the test, right? So, um, um, yeah, I mean, standard deviation. Like if you want to compute standard deviation, usually it's gonna takes a lot of time. Because the formula of the standard deviation in general is kind of it's a mess. It's not an easy formula, right? With the square, etc. So yeah. All right, guys. Did anyone? Well, I think Yanini got the 1.32, right? The X bar.
I just did that to make sure that I'm writing it correctly, like
correctly. Okay. Yeah. That's all right. Yeah. It's yeah. Square times. Yeah. All right. So let's do it together. So so let's start with number one, the probability distribution, right? So the probability distribution, for each value of x, you assign the probability of x, right? So you have the values of x. So 0, 1, 2, 3, and then 4. And then there's a probability of X. Now, how do we compute the probability of X? So it's just you take the number of couples and you divide by the size of the sample, right? So for example, for 0, the probability that X is equal to 0, right? So you count how many couples. So the X, of course, represent number of kids. So you count how many couples with 0 kids. This is so number of kids is 0. Number of kids here is just 0, right? So you count how many couples with 0 kids. It's 15. So we have 15 couples with 0 kid, right? 15 divided by the size of the sample. In total, we have 50 couples. So that's 15 over 50, right? So it's just 15, the number of couples with 0 kids, over 50, which is the size of the sample. So 50 over 15, sorry, over 50, that's 0.3. So here, the probability that X is 0 is 0.3. Or if you multiply by 100, that's the 30%. Right? So yeah, so etc. So like for X is 1, that'll be 20 over 50, which is of course 0.4. So 20 over 50, that's 0.4. Now next, it's 5 couples with 2 kids. So probably that X is 2, that's 5 over 50. So that's a 0.1. Then we have 4 couples with 3 kids. So the probability that X is 3, that's 4, right? It's 4 over 50, right? So that's 8. 0. That'll be 0.08. And then for probability that X is 4, so the number of couples with 4 kids is 6. So that's 6 over 50, and that will be 0.12. 0.12. Okay, so that's your probability distribution, right? This table, that's what I call the probability distribution of X, right? This is the probability distribution of X, probability distribution of X. For each X, you find the probability of X, distribution of X. All right. Any questions so far, guys? So just multiply, the number of couples on the table by the size of the sample. All right. Once you have the probability distribution, then of course you can compute. So next, you need to find the expected number of kids of a randomly selected couple. So we said the expected number, that means the X bar, it means the mean, right? That's what we mean by the expected number. So we need, so number 2, we need to compute the mean. So X bar, the mean, let's write the mean first. So the mean X bar, so it's supposed to be the sum of X times PX, right? So now, so we're gonna use our probability distribution and to find the mean, right? So first value of X, is 0. So it's 0 times the probability of X is 0, that's 0.3, plus next value of X is 1, multiplied by the its probability, which is 0.4. So 1 times 0.4. Next value of X is 2, multiplied by 0.1, etc. Right? So 3 times 0.08, and then 4 times 0.12. Okay. So PEMDAS rule, of course, multiplication first. So this is again X bar. So multiplication first, of course, 0 times 0.3, 0 times any number is just 0. 1 times any number is going to be the same number. So 1 times 0.4 is 0.4. 2 times 0.1, that's 0.2. 3 times 0.008, that's 0.24.
and then plus 4 times 0.12, that's 0.48. All right, so then X bar, as I said, that will be equal to, so the sum is 1 point, so it's going to be 1.32. So the X bar is 1.32. So what we are saying here is that if you select a random couple, then what you expect as a number of kids is 1.32. Okay. Any questions so far, guys? Okay. All right. So that's for X bar. Now, next, the standard deviation, right? So S, well, we start with the variance. Let's start with the variance. So, first, so standard deviation. All right, so first step, we're gonna compute step one, gonna compute S square, the variance. So which is, so the formula was like X minus X bar square, don't forget the square, times P of X. So that'll be equal to, so when X, first value of X is 0, right? That's the first value of X. So it's 0 minus X bar. Come on. Okay. So it's 0. That's my X, my first value of X, minus X bar. So my X bar, I just computed the X bar, and we said it's 1.32, right? And then parentheses, then there is a square, right? Times, and then we multiply by the probability of X. So X here is 0. Probability that X is 0 is 0.3, right? That's from the probability distribution table, right? When X is 0, probability that X is 0 is 0.3. So times 0.3. Okay. Please, guys, I mean, if you have, I mean, don't be shy. I mean, you can unmute yourself if you have any question. So next value of X is 1, right? So that's 1 minus the same mean, of course. There's a square times the probability that X is 1. So that's from the table, the probability distribution. So when X is 1, probability that X is 1 is 0.4. So here it's times 0.4. 0.4, etc. So next it's 2 minus 1.32 times the probability that X is 2, which is 0.1. 3 minus 1.32 square times 0.08, right? This is probably that X is 3, 0.08 times 0.08, and then finally last value of X is 4, same mean minus the same number, the mean times probably that X is 4, that's 0.12. All right, so now you do the subtraction, right? You subtract. So 0 minus 1.32, that's negative 1.32 square times 0.3 plus. Next, it's 1 minus. So if you do 1 minus 1.32 with your calculator, that will be negative. It's negative 0.32 square. Okay, so because you have the square times 0.4. So as I said, again, guys, the negative here is going to be positive, right? Because of the square. Okay, the next step, everything is going to be positive. So plus 2 minus 1.32, that's 0.68. That is a square times 0.1 plus 1.68 square times 0.08 plus 2.68 0.68 squared times 0.12. All right. Now I'm done with the subtraction. Now I can move to the square. And because of the square, the negative is going to be positive. So like 1.32 squared. So that will be equal to positive 1.74, let's say, times the 0.3 plus, right? So the negative 0.32 times the negative 0.32, right? So that will be equal to 0.1. 0 times 0.4 plus, okay, so as you see, now everything is positive, right? This is positive, this is positive. The 0.68 square, so that'll be equal to 0.68 times 0.68, that's 0.46 times 0.1, okay, plus, so this is 1.68 square, so that will be equal to 2.82. 82, thank you, times 0.0. Thank you, Annie. Yes.
0.18.
Yes, 7.18 as you said. So yes, so this is 7. So 7.995 actually times 0.12. Now you do the multiplication, right? So multiply, you do the multiplications. So like first multiplication is 1.74 times 0.3, right? So then that will be equal to 0.522 plus. Next, it's a 0.1 times 0.4, that's 0.04. Next, 0.46 times 0.1, that's 0.046. Okay. 40, oh, well, yeah, 46. And then 2.82 times the 0.08, so that will be equal to actually 0.22. I think I have 222.5, but anyway, it's not, you can round, yeah, it's up to you. You can round up your numbers if you want. And then 7.95 times, 0.12, so that will be equal to exactly, this is 0.995. I think I have 954.
954. I got 861.
For the 7.95 times 0.12.
Yeah, because I don't know how you got 95, because 2.68 two times is
Square.
2.18. Yeah.
Oh, you're right. Sorry. You're right. This is sorry. Thank you. This is actually 7.18. Thank you. I'm sorry.
A lot of numbers.
Yeah. Sorry, this is 7.18. So you're right. So this is times 0.12. So this is, you're right. So this is actually
so it becomes
8.
86.
Yeah, it's
61. If you want.
Yeah, 0.861. You're right. Thank you, Yenny. Actually, yeah, I got the right or wrong number from my notes. Yeah. So then now we can just we can just add, and the ends
694.
Yeah, it's 1.694. Yeah, I got the same number. Yeah, thank you. So this is your S squared. So this is your variance. And then
okay, I was gonna say that we don't have to find the square root to that, because
yeah, we need of course. Yeah, we need to find the square root of that. Yeah, absolutely. This is step number 2. Did I write step 1? Yes. So step 1, that's this S squared, that's the variance. So then step 2, of course, step 2, that's the standard deviation. S, which is of course square root of S squared. So we need to take the square root of So S would be square root of 1.694, which is actually equal to 1. Let me see my notes. Yes, it's 1.301. Do you get the same answer, Yanine?
Yes, I did.
Yes. Okay. Okay. Perfect. Thank you. Any question, guys? Let me see the chat. Okay, there is something in the chat. I'm gonna just check what's in the chat. Yes. Yeah. Absolutely. Yeah. Yanine. Yeah. That's the standard deviation. All right, guys. So that's for. So that's for the standard deviation and the mean of a probability distribution. So next, let's see. So I mean, we are done with this section 6.1 actually. So we have like let's see. So we have like 15 minutes, and I don't want to start the new section in 15 minutes. So what I'm
I
gonna
have
do?
a question.
Yeah, please.
There is any difference with this standard deviation and the other that we have studied before, like when we use the X and everything? It is same thing?
Yeah, so we are computing the same thing. Yes, we are computing the same thing. Yeah, it's just the same thing. Yeah.
Okay, thank you.
So for the
It's just
Go ahead.
say it again.
No, I
It's
was
just that.
something, but go ahead, finish that first.
Yeah. Yeah. So what we had before. So what we had before is like we have like some data values, right? With the n size of the sample,
Yeah.
etc. We had so the data values are your x. So here it's exactly the same thing. It's just the previous formula. It's the same thing. It's just like in this case when we have like a discrete variable, like here, this formula would be easier to compute than the other one. So, but they are the same. It's just the same thing. Okay. I mean, actually, you can use this formula to compute the standard deviation of your data set. But the thing is, I mean, in this case, when we have a probability distribution, it's easier to use this formula. But yeah, it's of course it's the same thing. Okay. Because in the formula we had before, your x. So here you see your x is just like a 0, 1, 2, 3, 4, etc. So it's kind of easy to compute the x here. But before, like when we have like a data set, your x, can be any number. It can be, I don't know, 50 or etc. or wherever. So yeah, but the two formulas are equivalent. They are the same.
Answer for this one, what would be the sentence? 1.3, 1.30 means what?
So yeah, so that's so the spread. So what we are saying here is that the spread of the probability distribution about the mean is given by the spread of the probability distribution about the mean is given by, so this S is 1.301. So what we are saying is, so the idea here is that you have your mean. Your mean is 1. What was our mean? Our mean was 1.32, right? So 1.32. Okay, that's your mean. So what we are saying here with this number, with this 1.301 is, so if you pick a random value of x, okay, then the distance, so what you expect in average as a distance between your x, the number x you pick and x bar is given by this s, is given by the 1.301. So what we are saying is that the distance in average, it's the weighted distance actually. So the weighted distance, between a random value of x and x bar, a random value of x and x bar is 1.301. Of course, your x, I mean, x can be, can be 0, can be 0, 1, 2, 3, 4, right? But the thing is, the values of x, they are not worth the same thing because, for example, 1, when x is 1, the probability that x is 1 is 0.4 or 40%. Compared to, for example, 3, the probability is 0.08. So what we are saying is the x equal to 1 is more frequent than, because it's a 40%, right? The probability that x is 1, it's 40%, right? This is 40%. Compared to 3, for example, it's just 8%. So x equal to 1 is more frequent than x equal to 3, right? They have more chance that x is 1, that when you select a random couple, the number of kids is 1. That's more frequent than, having 3 kids, right? So each value of x has like a different weight, or it's more important than, there's some values of x which are more important than others, right? Like the 1 is more important than 3. It's more frequent than 3, right? Etc. So what we are saying is, like, in general, so with this s, so the distance, the weighted distance, because some values of x that are more important than others, or they're more frequent than others. So in average, the distance between your x and x bar would be the 1.30 in average. Does this make sense? But I mean, that's like, that's like the interpretation of the interpretation of the standard deviation. That's the meaning of the standard deviation in general. Okay. All right, guys. Any other question? See the chat. Okay, no questions so far. All right, we have like 7 minutes. All right, so I can, oops, come on. What's going on with this iPad? All right, so I can give you, I guess, one more exercise. I mean, if you have time, of course, you can finish the exercise after the lecture, and yeah, I can probably give you one more exercise because I don't want to start the section like in 5 or 6 minutes. New section in 5 or 6 minutes. So here's another exercise. Exercise number 2. So we can have probably an exercise from the textbook. Let's see. So we can probably do exercise. Let's see, probably exercise 18. So this is okay. So this is exercise. This is exercise 18, page 256. All right. So here's x. Let's see. X represents the age. Let's see. So this is, so X. So X represents the age. Okay, this is X is the age. And the P of X, that's the probability of the death at this age. So that's the probability of, this is the death at this age. Okay, so we have the following probability distribution. So here's, so X is 60. Then we have 61, 62, 63, and then 64. Now, so the P of X, so this is the probability of death at, for example, when 60 years old, is actually 0.00756. Then we have death, the probability of death at 61 years old is 0.00825. I think my table is kind of small here. Sorry about that. I think I need a bigger, more space.
Professor, is there any way we can
Oh,
use the
so
first
yes.
numbers? Like, let's say if obviously if everything has 0.00 something else, those three numbers instead of all five numbers.
No, the thing is, you cannot drop the zeros. The first, the zeros after the
No, I
decimal.
understand that. I understand
Yeah.
the first, the zeros prior,
Yeah.
now after you see the first number. That's what I'm trying to say. Let's say we see 0.0020 and we 0.0020, and now what's after the 20?
So if your zero is after the 20, of course you can just, you can just drop it. Yeah. You're talking about the zeros, or like
No, I'm talking about all the rest of the numbers in general.
The rest,
yeah.
Well, here, because like in this problem, the numbers are kind of very small, but yeah, I mean, you can drop, I guess, the numbers after. So if you have like 0, 0, 20, and then I don't know, like 1, 2, or
1,
something.
2, 3,
Yeah, you can just drop the 1, 2.
Yeah.
So like what's really important is so you keep the first, the zeros after your decimal point, and then let's say you have a non-zero number, you need to keep at least, like, let's say the first two non-zero numbers.
Right. Yeah, that I know. I just want to make sure.
Yeah.
So, I know anything prior would be messing up the whole entire.
Oh yeah, of course. Yeah. So so this probability distribution, like we have like 0.00. I'm just trying to, I'm just so this exercise is from the textbook, so I don't want to change the numbers, because I guess that the answers, they would be different, if I drop like a number. But but so here, like in the textbook, it says the probability of death at the age 60 years old would be 0.00756. But in this case, I can just probably work with we can just work with the 0.075.
Yeah, that's what I mean.
Yeah.
That's exactly what I mean. No more, no less.
Yeah, okay. Because it's just because I don't want to have like different answer from the textbook. But yes, we can drop actually the 6. Like for 61. At the end of the day,
it just comes out to being round off. Like when you round it off, everybody gets the same number.
Yeah, same number, yeah. So I'm gonna just write down here the rest of the numbers. So X is 62. This is 0.0089, 63. So this is 0.00965, and then 64, the 0.01, well, 01, let's say just 01. So the question is, so this is your probability distribution. It says, so A, just write down the first A and B. So first you need to find, so what's the probability that Sarah will die in, well, this is just from the, okay. This is kind of easy, I think. Well, so what we can do probably is compute, probably the X bar, the mean. So the X bar. And then we can probably compute the standard deviation here. Anyway, so I guess, yeah, well, it's 120. So I guess I'm gonna stop here, guys. Tomorrow we'll start a new, I guess we can start a new section. And then, and again, if you have time, you can try to answer A and B in this exercise. But I don't think tomorrow I will have time to go. I won't go over this, I guess, tomorrow. All right. Thank you for listening, everyone, and hopefully I'm gonna see you tomorrow. Take care.
Bye. Yeah.
Professor.
Bye, Professor.
Have a great day. Thank you.
Bye,
Thank you.
Professor. Have a nice one.
Bye. You too. Thanks.